Good morning. In our previous discussion, we have discussed how to control corrosion by galvanizing and by anodizing. So today we're going to discuss how to prevent or control corrosion by cathodic protection. So what is cathodic protection? So before discussing what is cathodic protection, let us see why corrosion occurs. So corrosion of any metal or a specimen occurs because it occurs because flow of electrons from anode to cathode. So in order to satisfy the cathode demand of cathode, the metal which is acting as anode undergoes corrosion. So in order to prevent that, so we can prevent that by either converting the entire cathode, the anode as cathode, or by supplying the electrons to demand of, we can satisfy the demand of electrons of cathode by supplying electrons to cathode by some other external source. So you can prevent corrosion by supplying electrons to cathode by some other external source, or by converting the entire anode to cathode, you can prevent corrosion. So this type of technique is called as cathodic protection. So this cathodic protection is done by two methods. One is sacrificial anodic method, other one is impressed voltage method. So what is the sacrificial anodic method? What is impressed voltage method? We'll see one by one. So sacrificial anodic method. So here the metal to be protected from corrosion is converted into cathode by connecting it to metal which is anodic to head. So the metal to be protected from corrosion is converted into cathode by connecting it to the metal which is anodic to head. The metals, the base metals or the metals which corrode are usually iron, copper, brass, or these are the metals which undergo corrosion. So metals like zinc and magnesium are usually anodic to iron and copper, right, on brass. So they are more active. So the zinc and magnesium is used to connect to this. So when you connect the zinc and magnesium to iron, what happens when you connect zinc and magnesium to iron? Zinc will become anode and iron and copper will become cathode. So iron is getting converted to cathode. When you take iron and copper, so iron undergoes oxidation and copper is protected from corrosion. So in order to protect iron, you connect zinc or magnesium to iron. When you connect zinc or magnesium to iron, so immediately iron also become cathode and zinc start undergoing oxidation. So in order to protect iron, zinc is sacrificing itself. So zinc is sacrificing itself as acting as anode. It is called as sacrificial anodic method. Since zinc is sacrificing itself acting as anode in order to protect the metal, that is iron or some other metal, is called as sacrificial anodic method. So let us consider the best example as a ship. So the entire ship is made up of iron, right? So the base of the ship is made up of iron. So what happens, you know that ship undergoes differential aeration corrosion. So in order to prevent differential aeration corrosion, so what happens, the part of the ship which is below the water level acts as anode and the part of the ship is above the water level acts as cathode. So the anode undergoes corrosion, a hole will be formed and water enters the ship and entire ship will sink. So in order to prevent this, what we are going to do, we are going to connect a hull. What is hull? A hook type which is used to tie the ship in the seashore. The hull will be attached to the ship. Okay, so the hull will be made up of either zinc or magnesium. So as soon as you attach this zinc or magnesium hull to the base of the ship, the entire base of the ship will be converted to cathodic side. So now this zinc or magnesium will start undergoing corrosion. It will start to act as anode and supply electrons to the base of the ship. Slowly the hull undergoes corrosion, oxidation corrosion, and what happens, finally the hull will become slim, right? So since the hull is sacrificing itself in order to protect the entire base of the ship, it is called as sacrificial anodic method. Advantage, it is low installation cost, low maintenance cost, and it is simple method. So disadvantage of this is that it is having a recurring cost. So we have impressed voltage method. So impressed voltage method, it is used now to the major application of this impressed voltage method is for protecting oil pipelines, oil barrels, water pipelines, etc. So in this method, the structure to be protected from corrosion is made as cathode, and the inert metal will be made as anode, and the current will be supplied. It will be connected to the external power supply, DC power supply, and impressed voltage will be supplied. So impressed voltage, that is a small voltage, will be supplied to the entire structure. Voltage means electrons will be supplied. Since that entire structure is acting as cathode is getting electrons, it will not undergo corrosion. Okay, so here care should be taken care that equal current is supplied. If we are not supplying current equally, galvanic cells will form, and it may lead to smaller galvanic cells and may lead to smaller corrosion, and the entire thing may get corroded. You can see that metal to be protected is made as cathode, this one, and inert anode is used because connected to the external power supply above the ground level. Such type of things can be seen in your petrol pumps, where petrol pump, you know that as soon as you go, petrol, diesel, everything will be supplied filled to your fuel tanks, but the entire oil tank is in your underground. So in order to protect that, you are going to connect negative and cathode. You are going to make that entire oil barrel as a cathode, and inert anode will be there. So you are going to supply, give power supply. Okay, since the entire oil barrel is acting as cathode, it will be protected from corrosion. Okay, there is a small, I mean, the advantages is low maintenance. One installation can protect large area of metal, but impressed voltage should be uniform, otherwise localized corrosion occur. Why localized corrosion occurs? Because local galvanic cells will form here and there, and because of that corrosion may occur. A small video here, animated video is present here, which shows the cathodic protection by impressed voltage method. We'll understand it better. You can see impressed current and sacrificial anode measure difference. So usually you prefer impressed voltage method because only voltage is less. So sacrificial anode method, again there is a loss, metal undergoes corrosion, one or the other metal undergoes corrosion. So impressed voltage only you are supplying current in a smaller quantity, right? Thank you.